ANSYS Simulation Lecture 2, Deflection of a Cantilever Beam. In SolidWorks, enter a part file, and on XY plane, enter sketch mode, draw a rectangle, 50 by 50, and extrude it into 1 meter long. Save the file on desktop. Enter ANSYS Workbench. And open the study on solid mechanics, static structure analysis. So this is the geometry imported from SolidWorks, and static structure, drag and drop on the geometry, and there's a linkage between the geometry and the CAE structure. So this is the first step. The second step is the material. We'll edit material in the material procedure, duplicate the material, and change the Young's modulus into 3 times 10 to the 11th, or this is 10 to the 6th, and this is 10 to the 5, right? So it is 3 10 to the 11th, and Young's modulus of 0.3. So we go back to project and enter edit mode, and we'll enter mechanical procedure. Actually, the mechanical procedure is the software running the CAE work. So this is the mechanical, ANSYS mechanical interface. For the geometry here, we have to connect the geometry with material. And this is the material structure steel 2. That we have changed properties from Young's modulus of 2 times 10 to the 11th into 3 times 10 to the 11th. So the material properties changed. So we link or connect the material with the geometry. So this is step 1. This is step 2. Step 3 is meshing. Update the mesh. Step 4. Fix support on this area. Apply. Concentrated force on this area. Apply. Direction of the force. Choosing this line. Choose the line here. This line. And direction of the force, this line. It's difficult to choose from the line. Okay, and toggle the directions. Apply. The magnitude of the force. So this is the fourth step. Applying boundary condition and force, and the phase of force application, and the direction of force, and the magnitude of the force. So we have finished with the 4 steps for preprocessors, and the problem is totally defined up to this point. So we're going to solve for the problem. Before we solve problems, we need to tell the software what the result we need, and go ahead and solve the problem. And for the result, first of all, we'll see if the unit is what we need. Actually, it is the unit that I need in millimeters. So I can probe the deformation here. It is 0.2125. And I can make the mesh finer. Insert a sizing geometry body. and the element size to be 0.01. This may be too small. I'll choose 10 instead, 10 millimeter, and mesh, update again. And I got a final mesh. This is a mesh size of 10 millimeters. So I'll solve the problem again. And now the deformation probe is 0.2129, so 0.213. It is very close to the theoretical value. So this is the second lecture, the deformation or deflection of a cantilever beam.